Hello and welcome to AWS On Air. I'm A.M. Grabelny. I'm a solution architect here at AWS, one of your AWS On Air hosts, bringing you all the tech content that you crave. I'm here with my good friend Kyle. Kyle, please tell the audience.
Hey, what's going on, everybody? My name is Kyle Lee, and I am a senior developer advocate on the AWS Amplify team, and I'm here to learn something about graph databases or something like that. That's why Dave is here. So, Dave, tell us a little bit about yourself and what's going on.
Hey, I'm Dave Beckberger. I'm a senior graph architect on the Amazon Neptune team, and I'm really happy to be here today to talk about some new features we had with releasing a Pandas integration for AWS Neptune, our purpose-built graph database here.
Got it. So Dave, tell me a little bit about what a graph database is, because I'm not really familiar with it, and what is Neptune?
So Neptune is AWS's purpose-built graph database offering, and a graph database is more generally is a type of NoSQL database that really focuses on working with data with very complex and rich connections associated with it. So when you're working with a graph database, you have entities or items and relationships between those items, and both of those are modeled as kind of first-class citizens in the data themselves. I like to say they're actually, the relationships themselves are stored as data. And this allows you to basically represent very rich, complex environments in ways that other types of databases and both relational and NoSQL databases don't really allow due to that sort of nature. But a graph, even more generally, is a data structure we're kind of all familiar with. We're all familiar with things like trees, linked lists, items like that. And a graph database is just a database that uses those sorts of data structures and stores them natively inside of itself.
Okay, got it. Yeah, I haven't had any experience with it myself. Am?
Yeah, I actually have. I mean, Dave, too, I wanted to talk a little, the two objects that you have in most graph databases, right? A vertex and an edge, right? Can you explain maybe a little bit? I'm throwing you a bit of a curveball here, but can you explain a little bit about those two objects and how they're related and how they kind of create the graph themselves?
Yeah. So if you actually think about it, if you're going to go work on any sort of data problem, the first thing you're going to probably do is go up to a whiteboard and start drawing circles and lines between them, or boxes or a line between them, depending on what your preference is. But you're going to start drawing that where you have something like a person will be represented as a box, as an entity, and a company will be represented as a box or an entity, and then you'll have some sort of relationship between them or connection between them where you represent a line that basically says it works at or is employed at or owns or whatever the sort of things is. And what you're building there is basically a graph type of structure where you basically, those boxes or those circles are representing the entities or the nouns in kind of a domain: people, company, address, phone number, things like that. And the relation and the lines that are connecting them together represents how those two things are related, often kind of thought of as the verbs in those sorts of scenarios. Owns, works at, shipping address, home phone, things like that. The sorts of kind of connections between those sorts of items. And that's really what you're building there, is that is a graph. And that is the sort of data structure and data model that you store inside a graph database.
Yeah, Dave, I wanted to bring that up because, I wanted to talk a little bit about my experience and then hear more from you about what other people are building with graph databases. I had the opportunity to build essentially a file system. So, one of your vertexes is a file, another vertex is a user who has access to that file or doesn't have access to that file. And that's the edge relating them is, the access permissions. And so, moving down a folder tree, for example, right, you might have folders that also have an edge to that file, right? The folder contains that file. So yeah, exactly. You're describing, right? You've got these nouns, you've got these verbs connecting the nouns. What are some other use cases that people are building?
Yeah, that's what I was curious about. Yeah, go ahead.
Yeah. I mean, actually, what you just talked about there is one we've seen a lot of customers do. And I mean, in something like that is even a little bit more simplistic than some we've seen other customers, because sometimes it's not only do you have access to this file, it's this person has access to this file from 8 to 10 on Tuesdays and Thursdays,
Right.
sort of level, where it's not just a matter of a single relationship, but that relationship really has additional criteria or additional properties on top of it, which a graph database allows you to represent is basically properties specifically on that relationship. And we would kind of classify that under what we generally or broadly call security graphs. And security graphs can range from things like that to complex Active Directory type permissions models, things like that. You're parts of these groups have access to things, and being able to look for things like, okay, are there people that have access to something that they probably shouldn't have access to? Another common security graph use case is something like your AWS infrastructure. If you start thinking about this, your AWS infrastructure is multiple layers of different security groups and VPCs and IAM roles and things like that, and being able to kind of look at that entire graph of your AWS resources and being able to say, okay, do I have anything that has a star in an IAM role, something like that? We all know we shouldn't do, but sometimes they're in there. And if they do, what is using that role, and what is that, what is using that role, and is that maybe like EC2 instance or something exposed to the internet where it's starting to really kind of create a threat vector that I need to rapidly work on resolving, things like that. So that's what we kind of broadly classify as security graph use cases. Other use cases of graph databases, I mean, the kind of canonical one is a social network. How do I know AM? How do I know Kyle inside, how are we connected?
Okay, so like friends and followers and things like that. Oh,
friends
okay,
and
so like
followers,
complex relationships and things like, okay.
Yeah, especially when it's more like, it's not so much the find me all the people that you follow. It's when you have the really, something like that could be done in a relational database with a single join. But if I wanted to really dive in and say, how are these two people related? I don't know if that's one join, 10 joins, 100 joins. They may not be related. That's when you start to kind of start to really run into problems with other data stores that graphs solve really well. Beyond that, we also have use cases around things like knowledge graphs. So you have many disparate data sources or data silos inside of any organization. Maybe you're an e-commerce site and you have a warehouse database and an inventory database and a sales database and a customer support database. And you want to link these together to see how customer ABC has interacted with these different data sources over time, to be able to kind of get that holistic view of customers. We have identity graph use cases, which are things like, I connected to this website from my mobile phone. I connected to this website from my work computer. I connected to this website from my home computer. And I want to be able to link all of these together to be able to kind of provide maybe a more personalized recommendation experience based on these different methods I connected to and the things I looked at those times. And then kind of the last one that comes up a lot when you think about graphs, or when people have talked about graphs in the past, is this concept of fraud. This is actually what we're going to talk in demo a little bit today. But really common use case in fraud is being able to find things like fraud rings. I want to find groups of people that are potentially linked together in sort of a guilt by association type mechanism, where if I'm working, if I'm connected to AM through, maybe we use the same address for shipping or something like that, and he's flagged as a fraudulent user inside of the system for some reason. That makes me a little bit more risky of a transaction and things like that.
I am a fraud, Dave. Thank you for recognizing that.
I mean that.
Oh,
okay,
sorry.
Potentially fraudulent.
I did.
Well, Dave, I heard demo.
Yeah,
So,
Kyle,
like,
he said our wake word, right?
Yeah, like I'm a
word.
visual person. Like, I kind of want to see this thing in action. Can you show us the demo?
Absolutely.
Oh, okay. Here we go. We see your screen.
Yeah, so what we're actually looking at here is, this is a feature of Neptune. It's called Neptune Notebooks. What it is basically built on top of Jupyter. So Jupyter Notebooks, if you're a data scientist, data engineer, this probably looks very familiar to you as far as what is in there. And what we're looking at here is a set of Jupyter magics or built-in commands that we had that basically allows you to work with Neptune in sort of an IDE way. So you can come in here, use these magic commands, like this one case, I'm using OpenCipher, which is one of our query languages. And I'm basically running this command that basically allows me to kind of see what my fraud graph looks like.
You
So
didn't have
what that
to
did,
set up. Sorry, Dave. You didn't have to set up this Jupyter notebook yourself, right? As a feature of Neptune,
when you create a cluster of Neptune, or even after you create a cluster of Neptune, you have this ability to run to basically create these. We call them Neptune notebooks, which basically will run as a hosted SageMaker notebook.
Nice.
At the same point, if you already have your own Jupyter infrastructure, this is an open source package, so you can actually install and run this on your local environment or a shared environment. As long as it has access into the VPC that Neptune runs in, you can use this and basically start running these commands without having to do a lot of extra work. It's kind of like this is the way we kind of provide for developers to be able to work inside the system.
Yeah, very cool.
But I know Kyle said he likes pretty pictures here.
Yeah.
So this is sort of the
Gorgeous. Ooh.
This is sort of what a graph looks like. In this case, we basically pulled back. We found a specific account, and we found all of the items connected to this. So this, in this case, you could sort of think of this if you're from a relational database as basically doing a bunch of joins to a set of normalized tables here. We have transactions here. It looks like we have 5 transactions that this specific account has done. They have connected through a single computer here and an IP. They have an email address. They have a home address, a birth date, and a phone number. So kind of gives you an idea of the types of information that's stored inside this graph we're doing. As I said, what we're going to be looking at here is actually basically how you can use this new integration with Pandas to be able to look for fraud rings.
You said pandas?
Pandas is it's a popular Python library that is basically it deals with allows you to basically build data in a tabular format. So you can kind of think of it as rows and columns.
Got it.
And it's sort of like the lingua franca of most Python libraries, where you basically everything sort of talks to it both as an input and as an output. And what we're kind of showing here is basically the integration we built to make it easy for customers of Neptune to be able to use that. Not going to necessarily walk through all of these, but basically what we've done here is we're being able to show that you can also not just pull back everything connected to it, but in this case, we've filtered it down to only pulling back what we'll call the features of the account or the non-transactions associated with this. In this case, addresses, birthdays, phone numbers, email addresses, things of that nature. And then being able to kind of show how you can use this graph database to basically find connections between items, because this is starting to lead to that whole kind of fraud ring analysis that we were talking about, where it's that guilt by association sort of construct. So being able to use a graph database to find these potentially not easily found connections between items, to be able to pull this sort of data back. So in this case, we can see we have this account. It's connected to this other account that uses the same IP address. Maybe it's your partner, your wife, your husband, your spouse, your kids, something like that. It's connected to this account through using the same address. And then there's 3 different ones that have the same birth date. And, these 2 accounts are sharing an email address.
Yeah. So that bottom left corner is kind of what's starting to actually put it together in my head of how graph databases are useful, where you have these 2 accounts that are connected by, it looks like a birthday and an email address. So now I'm kind of seeing like the benefit of a graph, because like you said, multiple joins, it's going to start to get a little bit tricky.
Yeah, especially if you want to be able to say, okay, how many different features do these 2 accounts share? That's not going to be easily expressed in other, in a lot of other databases and things like that. Whereas those sorts of things are relatively easily expressed inside graph query languages.
Got it.
Hey, Dave, in terms of data modeling, and this may be a distracting question, so please tell me if it is and we could skip it. But when would you decide to make like something like a birthday or an address a property on that vertex rather than like another vertex itself that's connected back to that account through that edge? How do you?
That's actually That's actually a really good question and a really common one we have when we talk about graph data modeling. And really, it kind of comes down the way I always look at it. If you're doing a property graph model where you have, those nodes, those nodes or those vertices, those edges or those relationships connecting them, and then you also have this concept of properties or attributes. It really comes down to how you want to be able to use them. If you want to be able to use them as like to filter on, I want to find accounts with this specific email address, I would add it as a property on the email node. If you want to be able to say how many different accounts use this email address and you want to use it to connect those items together, I would create a node, basically a separate node for something like email address or phone number. Or you can actually, there's a lot of times you may want to denormalize it because you have use cases for both and be able to store it as both a node and a property.
Got to ask that.
Denormalization in graph databases is sort of a normal thing, just like it is inside of any other database, because it's really about, when you go to write your traversals or your graph queries, it's really about how, the speed's going to very much depend on how much of the graph I have to touch in order to answer this question. And the less of the graph I can touch to answer the question, the faster my query is going to come back. That's not unique to graphs.
I'm so happy I asked a good question.
You did good, AM. You did good.
That's all I ever wanted to hear from you, Kyle. Thank you.
So what we have here is just a kind of a visualization of all of the different accounts that share features across them. I'm not going to jump too much into the details there because I kind of want to get to the next part of the demo, which is really the fraud ring aspect of it. And this is really kind of the new part here, which is this integration we have with Pandas data frames. And specifically, we integrate with it using, there's an open source library called AWS Datawrangler. And we decided to build an integration with that because it really enables customers. It enables customers to more easily use Neptune with data science type workflows or data engineering type workflows, because it really removes the undifferentiated heavy lifting of having to manage connections and then, marshal data and objects between, the response format from the database into something they can use with other data formats, and then, back and forth, that sort of thing. So what we actually see, what I have highlighted here is these 3 lines is all it takes to be able to create a connection to Neptune, to run a query, in this case, an OpenCipher query, and to get back a Pandas data frame of that information. And that's really kind of...
I had a question about like this query, because like I haven't touched databases very much, but when I have, it's been like using SQL queries. So like this looks a little bit different than that.
So this is actually a language that we recently released support for in Neptune. It's called OpenCipher. It's a SQL-inspired language. But it's a SQL-inspired language that's really focused on the types of things that a graph database will allow you to do. So if you look at this sort of ASCII art sort of look, where you're saying, I want to match. So I want to find everything in my database where it has an account that has an edge coming into it called feature of account that basically attaches to another node that also is attached to a feature of that is also attached by an edge called feature of account to another account. So in this case, I'm basically wanting to find those features that basically share a phone number, an email, things like that. So OpenCipher is very much a pattern matching language. So this sort of parentheses bracket sort of ASCII art allows you to build out what you would like it to go find inside your database. So it's sort of a pattern matching type syntax that OpenCipher uses, which is similar to SQL, but not exactly SQL, because SQL is built for dealing with, rows and columns, not dealing with entities and relationships.
Got it. So we have like about 2 minutes left. I was curious, like, is there anything else that we need to show the audience, like in terms of getting started, or anything else cool that you have to show us?
Yeah. So we got just a couple minutes here. What this is actually a notebook that is out there and available today. And it walks through basically how you would exactly go through the process of using this new AWS Datawrangler integration to find fraud rings inside data, looking for things like strongly linked communities inside that data, and then basically finding the most important members of that community in order to be able to use that as a starting point for basically an online investigation. So you can sit here and analyze the results, and then explore their connections to start really determining if they are or are not fraudulent. And then if they are fraudulent, how do you mark them as fraudulent and find other connected items? So really it kind of walks through here's your account, here's how you analyze your account, and then here's how you flag potential items. And then here, as a human, how do you go and actually analyze that information to be able to do that? And all of this is available through, as I said, our Neptune notebooks as open source package. So we actually have 3 notebooks that highlight this. First one being about fraud ring identification. Then there's one that kind of walks through how to identify first person or synthetic fraud. And then the last one is logistics analysis for transportation networks. So those are kind of the places that come. These are 3 tutorials that come with our Neptune notebooks installations that you can go use today.
I love it, Dave. That's so great. So go check out those notebooks. Dave, also very happy that you took some of the tediousness out of, managing connections, data coercion, right? Like that stuff that, like I said, a little tedious to write. So thank you.
Yeah.
To you and the
oh,
Neptune
absolutely.
team. Kyle, thanks for joining us too. Dave, thanks for showing us all this about Neptune. Go check it out and stay tuned for more content coming right at you on AWS On Air. Thanks, everybody.
Thanks for having me.